Dear students, welcome to HomeLearns class. In this class, you will study about trigonometric functions. But before going to the trigonometric functions in detail, let's summarize the trigonometric ratios which you have studied in your previous class, that is class 10. The summarization of trigonometric ratio is necessary because on the ratio of the trigonometric ratios, trigonometric functions can be easily understood. First of all, let's summarize within a minute about the trigonometric ratios. Trigonometric ratios for acute angle are the ratio of sides of a right angle triangle. Let there be a right angle triangle. This is the right angle triangle OAB. This is the theta angle. And the adjacent angle to the theta is of 90 degree, that is the perpendicular. The side is hypotenuse, this is the base, and the side which have the 90-degree angle is known as a perpendicular. According to the Pythagoras theorem, perpendicular, square of perpendicular plus square of base is equal to square of hypotenuse. Based on this right angle triangle, let's summarize trigonometric ratios. Sin theta is P upon H, perpendicular and hypotenuse. Perpendicular oblique hypotenuse. Cos theta is base on hypotenuse. Tangent theta is perpendicular oblique base. Cot theta is base oblique perpendicular. Secant theta is 1 upon cos theta. It means it is H oblique B. And cosecant theta is H oblique P. As we know, there sin theta is 1 upon sin theta is 1 oblique cosecant theta. Cos theta is 1 oblique secant theta. And tangent theta is 1 oblique cotangent theta. Why there are only 6 ratios? There are no 7 ratios, no 8 ratios. Because there are 3 sides and combinations of these 3 sides become 6. Hence, these are the 6 ratios. So I hope you have remembered this type of ratios, and in the further we will study about trigonometric functions. Let's come to the what is the trigonometric functions. Consider a unit circle with center at origin. This is a circle. Let's draw a circle. This is circle. In a circle, this is the origin. X coordinate, Y coordinate. 4 quadrants are there. Y minus, X minus. Okay. Now, let's consider a point P is here. P is such that this is a triangle, right angle triangle A B. P is such that AB and these coordinates are 1, 0. Why this 1, 0? Because this is positive here. Why? Here in the y is 1, x is 0. At point C, this is the B point. At point C, this is x is -1 and y is 0. And at point D, x is 0, y is -1. These are the four quadrants in this. Now, if we define here, we define cos x is equal to A and sin x is equal to B. Sin x is equal to B. Why? Because OMP is a right angle triangle. Right angle triangle. OMP is a right angle triangle. According to the Pythagoras theorem, OM square plus MP square is equivalent to OP square. OP is 1, OM is A square, MP is B square, then OP is 1. A square plus B square is equal to 1. Hence, we put the values of cos A and sin x B and cos x A in it. Then it becomes cos square x plus sin square x is equal to 1. So as we know that one complete revolution subtends an angle of 2 pi radian at the center of the circle. This complete, we go from it is going from here to here, then again it completes revolution of 360 degree. That is the 2 pi radian. Angle AOB, angle A, this is the point A, angle AOB, this angle is pi by 2. Complete revolution is 2 pi radian. And this is the 1/4 part, one quadrant. There are 4 quadrants. These are the 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So, quadrant 1, every quadrant is of pi by 2. This is the pi by 2. A, B, C, D. It means this AOB is pi by 2. AOC, angle AOC is pi. Angle AOB is pi by 2. Angle AOD, this angle 3 pi by 2. and this is 2 pi radians. So these are called quadrantal angles. For all angles which are multiples of pi by 2, the multiples of pi by 2 are called quadrantal angles. All these are the quadrantal angles because there are four quadrant 1, 2, 3, 4. The coordinates of the axis are 1, 0, 0, 1, -1, 0, 0, -1, all respectively. Therefore, quadrant angles we have x, y, the coordinate points, the coordinates at A 1, 0, B 0, 1, x is 0, y is 1, C -1, 0, at D 0, -1. So these are the four quadrants, and four quadrantal angles we have cos 0, cos 0 degree. Cos 0 degree is equal to 1. Sin 0 degree is equal to 0. Cos pi by 2 is 0. Sin pi by 2 is 1. Because sin pi by 2 lies in this. Cos pi is -1. It is the -1 in this area, and sin pi is 0. Cos 3 pi by 2 is 0, and sin 3 pi by 2 is equal to -1. And cos 2 pi is equal to 1 again. Sin 2 pi is equal to 0. It means sin 0 and sin 2 pi is equal to 0. So we take one revolution from point P. Like this is the point P. We have taken the one revolution complete. Again, if we goes from P and we start from P, if x increases or decreases by a multiple of 2 pi, values of sine and cosine functions don't change. Values of sine and cosine functions don't change. 1, 0, 1, 0. Okay. So from this conclusion, we reach on a conclusion that sine 2n pi plus x is equal to sine x, where x, sine x, n belongs to any integer. Or similarly, we can write equation for this is also cos x. Why this? Because we reach on conclusion that when we complete one revolution, then sine 0 to 2 pi, there is no, the values of cos and sine don't change at 0 and 2 pi. Furthermore, if sine x is 0, sine x 0, if x is 0, plus minus pi plus minus 2 pi plus minus 3 pi. That is integral multiple of pi, and cos x is equal to 0 if x is equal to plus minus pi by 2 plus minus 3 pi by 2 plus minus pi by 2, and so on. So we define trigonometric function in terms of sine and cosine functions, and in the ratios we have also seen in the previous that sine x is 1 upon cosecant x. So cosecant x is 1 upon sine x. Secant x is not equal to n pi. Secant x is 1 upon cos x. Similarly, tangent x is sine x upon. We have defined these two, sine x, cos x. Let's define cosecant x functions. Cosecant x is 1 oblique sine x, where x doesn't belong to n. N is an integer, n pi. Cosecant x is 1 upon sine x. X doesn't belong to n pi. N is any integer. It means sine at 2 pi is equal to 0. 2 pi is equal to 0. It means 1 upon 0, and this cannot be defined. But this must not be that, n pi. And secant x, similar also. X is not equal to 2n plus 1 pi by 2, where n is any integer. 1 by cos x means, again, if this is the condition, x is an integer multiple n and it is the odd number, then it would be 0, and this is not defined. And tangent x, sin x upon cos x, similar to n plus 1 pi by 2. And again, cot x is cos x sin x. X is not equal to n pi. So we have shown that for all real numbers at the initial stage, I have shown you also that a square plus b square is 1, cos square x plus sin square x is equal to 1. So for any real number, sin square x plus cos square x is equal to 1. And these are the identities. These are the identities. And others identity also, 1 plus tangent square x is equal to secant square x, and 1 plus cotangent square x is cosecant square x. These are the trigonometric identities. In the earlier classes, you have also studied, as shown in your table in your book also, that you have studied the values, trigonometric ratios for at 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. Okay. And in this, let's draw a table. 0 degree, 5/6, 5/4, 5/3, 5/2, pi, 3 pi/2, and 2 pi. Means all quadrants, 2 pi. Sine, cos, tangent. If you know the values of two functions, sine or cos, or three functions, sine, cos, and tangent, that then you can calculate remaining also, because all others are the reciprocals of this. Like cotangent is the reciprocal of tangent, cos is the reciprocal of secant, sine is the reciprocal of cosecant. Again, at sine 0, sine is 0, cos is 1, tangent is 0, because tangent is sine oblique cos. At pi/6, pi/6, it is 1/2, √3/2, and 1√3. You have studied in your earlier classes also about this. 1/√2, 1/√2, 1. At pi/3, pi/3 means 60 degree. At 60, sine is 0, cos is -1, and tangent is √3. At 90 degree, sine is 1, cos is 0. This is not defined. At 180, sine is 0, cos is -1 because of its quadrant. In this quadrant, sine is positive, and this is not defined. 3/2, if it goes to third quadrant, -1, 0, and not defined. And 0, 1, and 0. All these values can be defined. I hope you understand it very well. Let's draw a circle. There are 4 quadrants. This is the quadrant first, quadrant second, quadrant third, quadrant fourth. I will show that in the quadrant first, all are positive. Means sine to cosecant. All are positive. In second quadrant, sine and cosecant are positive. In third quadrant, tangent and cotangent are positive. And in fourth quadrant, secant and cosecant. Secant and cos. Secant and cos are positive. Tangent, cotangent, secant, cos, sine, cosecant. $90, $180, $270. If we goes again, this is a complete revolution, 360 degrees. That's the complete quadrant. The coordinates are 1, 0, 0, 1. This is the x. This is y, positive. Then here x negative means 0 minus 1. X minus 1. X is minus 1, minus 1, 0. And then 0 minus 1. Let's sign of trigonometric functions, either that is positive or negative. I have clear with the help of this diagram that all are the positive in first quadrant. In the second quadrant, sine and cosecant is positive. In third quadrant, tangent and cotangent positive. In fourth quadrant, secant and cos are positive. Let's discuss it more. How this becomes positive or negative. Let's draw a circle. This is x-axis. This is y-axis. Y-axis, x-axis. A 1, 0. B 0, 1. C minus 1, 0. And D 0 minus 1. Y negative, x negative. Okay. Now this is the origin. We draw perpendicular. This is the P point. Here AB. This is B. This one A. This angle is X because it's going from. But if we draw, this would be the negative angle. Then this is the minus X angle. So that becomes minus, means P, if we go from P to Q, it becomes A minus B, and at P it is AB. If we go from this side or from this side, if A to Q, A minus B, A to P, A, B. Now in that triangle, A, O, P, this is the A point. So angle AOP is X. Angle AOQ is minus X, because this is the clockwise direction. If angle is in clockwise direction, then that becomes the negative angle. Otherwise, the angle in anti-clockwise direction, that is the positive angle. Therefore, cos minus X is equal to cos X. Sin minus X is equal to minus sin X. For every AB, A is between this minus 1, 1, and B is also between this. Then we can state that minus 1 is cos X, minus 1 sin X is minus 1 to 1 for all X. In the classes, we learned that in the first quadrant means 0 to pi by 2. A and B both are positive. A and B both are positive in first quadrant. But in the second quadrant, pi by 2, x to pi, A is negative, B is positive. A is negative, B is positive. In the third quadrant, A and B both are negative. And in the fourth quadrant, A is positive and B is negative. Similarly, for this quadrant, cos 0 is positive. Cos x is positive, 0 to pi. Cos x is positive for 0 to pi by 2, but negative for this. It is negative for this. It means here it is negative. And it is also positive for 3 by 2 less than x less than 2 pi. It is positive in these two quadrants. Means cos is positive in these two quadrants. Cos is positive in first and fourth quadrant. So likewise, we can find the trigonometric functions for different quadrant also. That sine is positive. Sine is positive in first and second quadrant. Cos is positive in first, but not in second quadrant. Tangent is positive in first, cosecant in first, second in first, cot is in first. Means in first quadrant, all are positive, A and B. But in the second quadrant, cos is negative, tangent is also negative, secant is also negative, cotangent is also negative, but sine is positive. In third quadrant, sine and cos are negative, but only tangent and cotangent are positive. In fourth quadrant, cosecant and secant is positive, else all are the negative. The domain and range of trigonometric functions. What are the domain and range of trigonometric functions? From the definition of sine and cosine functions, we observe that they are defined for all real numbers. So we observe that for each x, sine x is less than equal to 1 and greater than equal to -1, and cos is also in this. The domain of y is equal to sine x, and domain of y is equal to cos x. So is the set of all real numbers that is in the interval -1 to 1. That is the domain. Because cosecant is 1 upon sine x. The domain of cosecant is the set of real numbers. And x is not equal to n pi. N belongs to integers, as we have already studied this. Then range domain of y is equal to secant x. Again, that is 2n plus 1. All we are observed. So now we discuss the behavior trigonometric functions. We have the following tables in first quadrant, second quadrant, third quadrant, and fourth quadrant. Like the table in your class. Oh, sine in first quadrant, first, second behavior of these, third, fourth. In the first quadrant, it increases from 0 to 1, sine. But in second quadrant, it is decreases from 1 to 0. In the third quadrant, it decreases from 0 to -1. And in the fourth quadrant, increases from -1 to 0. How? Let's think. Increases from 0 to 1, x. Then decreases from 1 to 0. Then decreases from 0 to -1. Then increases from -1 to 0. That's the behavior. So you can state this for others also, like cos. Cos decreases from 1 to 0 in the first quadrant. In second quadrant, it again decreases from 0 to -1. In third quadrant, it increases from -1 to 0. And in fourth quadrant, it increases from 0 to 1. And tangent, cotangent, secant, and all. For the tangent, it increases from 0 to infinite. In first and third increases 0 to finite, and second and fourth minus infinite to 0. And cotangent decreases with the same, and secant increases in first two quadrants from 1 to infinite, minus infinite to -1, and decreases in these. So graphically, we can represent values of sine and after an interval of phi. So values of cos and secant will also repeat an interval of phi. So we can show it graphically also. But at this time, it's not needed to represent these graphics. Let's do some examples on the base with trigonometric functions which we have done till now. And after solving all these examples, we will solve the exercise 3.2. Example 6. If cos x is -3, 5, cos x is equal to -3/5, x lies in third quadrant. In this quadrant, first, second, third, and fourth. Find the value of other 5 trigonometric functions. Cos x is -3/5. Cos x, it means secant x is -5/3. We have the formula sin square x plus cos square x is equal to 1. Then cos square sin square x minus 3 by 5 square is equal to 1. Sin square x plus 9 by 25 is 1. Sin square x is 1 minus 25 by 9. Or minus, so 9 by 25. 9 by 25. 9 by 25. And it is 16 by 25. And sin x is 16 by 25 root, it is 4 by 5. Sin x is 4 by 5. That is in the third quadrant. Sin x is negative in the third quadrant. Therefore, sin x is minus 4 by 5. Sin x is minus 4 by 5. We also cosecant x is the reverse of the sin x. It becomes minus 5 by 4. We have the four values: sine, cos, secant, and cosecant. Now tangent. Tangent x is sin x upon cos x. Sin x is minus 4 by 5. Cos x is minus 3 by 5. Minus to minus cut. 4 by 5 into 5 by 3. It's 4 by 3. The cos tangent is 4 by 3. And cotangent is reverse of 1 by tangent x. It is 3 by 4. That's the values for all of these functions. Trigonometric identities to be learned better like this. Now the next example, example 7, I will do only this example for you, and okay, 1 and 2 examples, don't worry. If cot x is given, cot x is minus 5 by 12 and x lies in second quadrant. Find the values of other 5 trigonometric functions. If cot x is minus 5 by 12, then tangent x is minus 12 by 5. Why in second quadrant? In the second quadrant, as you have studied that only sine and cosecant are positive, others are negative. It means in the second quadrant, tangent and cotangent both would be negative. We have the trigonometric identities. 1 plus tangent square x is equal to secant square x. 1 plus minus 12 by 5 square secant square x. 1 plus 144 plus 25 secant square x. 169 divided by 4 secant square x. And secant square x is secant x is root 169 by 25, and it becomes 13 by 5. In the second quadrant, secant is negative, hence secant x is negative 13 by 5. Cos is minus 5 by 13. But in the second quadrant, only sin x. Now, what is the sine? We have the tangent We have cosecant tangent x is sin x upon cos x. Sin x is tangent x into cos x. We have both the values. Tangent x is minus 12 by 5 minus 5 by 13. Minus to minus cancel 5. It is 12 by 13. Now, sin x is 12 by 13. Because it is in second quadrant, its value would be positive. And cosecant is also positive. It is 13 by 12. That's all about this. I hope you understand the questions well, and now you can calculate the sums. Find the value of, next example is, find the value of sine 31 pi oblique 3. pi oblique 3. We know that value of sin x repeats after an interval of 2 pi. We can write this as 10 pi plus pi by 3 in the fractional value. This becomes sin pi by 3, and sin pi by 3 is root 3 by 2. That is the value. Sin root 3 by 4 pi by 3 is root 3 by 2. Now, next question is, find the value of cos minus 1710 degree. Minus 1710 degree. But we know that cos x repeats and after an interval of 2 pi. Means after 360 degree. 360 degree. Cos minus 1710 degree is equal to cos minus 1710 degree it's 5 into 360 degree, that is the 1800 minus 1710 plus 1800, that's the 90 degree, 90, and cos 90 is equal to 0. You can calculate the value of this. Till now, this is all about the concepts of trigonometric functions, trigonometric values, how you calculate what the quadrant you have studied. In the next class, I will solve for you exercise 3.2. It's very important to solve the exercises because through the solution of the exercises, we refresh each and every concepts of that topic. So please be in next class. Keep watching HomeLearns. Thank you.